Hello, my name is Cheryl and my topic is trigonometry. I'll only be talking about core trigonometry since this is supposed to be a short video. Trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangles and with the relevant functions of any angles. Most of these angles are in a triangle or just in any situation which has the shape of a triangle. Core trigonometry, which we'll be talking about, is used for triangles that have 190-degree angle. Mathematicians use sine and cosine values, these are trigonometric ratios, within a formula, as well as data from trigonometry tables such as decimal values, to determine the height and distance of the two other angles. Here we have a triangle ABC with an angle which is replaced with theta. The trigonometric ratios are sine, cosine, and tangent, also known as SOHCAHTOA. These ratios are based on the relationships between angles and side angles in a right triangle. These angles and trigonometric ratios can also be used to find the length of the sides of the triangles. Sine, which is is opposite over hypotenuse. Cosine is adjacent over hypotenuse, cosine is CA, and tangent is opposite over adjacent. The three sides of any right angle triangle, which are the opposite, hypotenuse, and adjacent, can be identified in various ways. The hypotenuse is the longest side of the triangle. The opposite is the side where the right angle of the triangle lays on, while the adjacent meets the opposite side of the triangle at right angles. The hypotenuse, which is the longest side, sometimes can't be easily identified by just looking at it. So you can identify the hypotenuse by checking which side faces the right angle. Any side which faces the right angle is the hypotenuse, and the opposite, it can also be identified based on any of the reference angles in the triangle apart from the right angle itself. For example, in triangle ABC, theta faces side BC, so the opposite of the triangle is BC. If it was to face somewhere like AC or AB, that would be the opposite. But since it's facing BC, that's the opposite of the triangle. And after you have identified the opposites and the hypotenuse, the remaining side would be the adjacent, since there are only three sides. Some examples of trigonometric ratios in use is this example here, where there are two similar triangles shown, triangle BAC and triangle EDF. According to the reference angles, we have two reference angles, C and F. For the first triangle, the cos of C is 4/5. This is because cos is equals to adjacent over hypotenuse. We'll first have to identify the adjacent side of the triangle and the hypotenuse. Using angle C as a reference, the hypotenuse of the triangle is 5, while the adjacent of the triangle is 3. So cos C will be equals to 4/5. Triangle EDF would be the same thing with triangle BAC, but would be a little bit different since we now have F as our reference angle, and F being our reference angle would face 4 as opposite and have 3 as adjacent, making the tangent of angle F to be equals to 4/3. Here in this triangle, the second example, triangle EDF is also similar to triangle BAC, and here we are using angle F as a reference angle, and based on angle F, the sine of F will be equals to 7/25, because if we are using F as a reference angle, it would face side ED, which is 7, and the hypotenuse, which is 25, which is 7 over 25, making the sine of F 7 over 25. Here's another example of the use of trigonometric ratios. Here we are given a specific angle which is 40, and we are asked to find the the sine of angle 40. We could have used the tangent, but you can see from here that we have two unknowns for tangents and the same for cos, so we use sine. Sine 40 would be equals to the unknown over 7. Sine is opposite over hypotenuse, and having 40 degrees as our reference point, the opposite will be the unknown, and the hypotenuse is 7. So sine 40 will be equals to the unknown over 7. You would have to cross multiply, which will lead you to have sine 40 times 7, which will be equals to the unknown. That is 0.6427876 multiplied by 7, and the unknown is 4.5, and which is approximately 5, and that's the unknown angle, the unknown side of the triangle. Here our reference angle is unknown, and we're supposed to find the reference angle here. And here we are given two sides, 6 and 8. 6 and 8, according to our reference angle, are the adjacent and hypotenuse, which is cos. So cos x would be equals to adjacent over hypotenuse. And since we are looking for x, we would cross multiply, which will give us the cos inverse of 6 over 8. Cos inverse is usually used when you're trying to find the angle of a triangle and not necessarily the sides. And so the cos inverse of 6 over 8 would be 41.1. The last example is a word problem involving trigonometric ratios. Karim wants to know how tall a building in his neighborhood is. He walks 100 feet from the base of the building and looks up to the top. He estimates the angle from his vantage to be 75 degrees. How tall is the building? Since we aren't Karim, we would have to imagine this. We would have to imagine walking 100 meters from the base of a building and looking up at an angle of 75 degrees. If we imagine that correctly, we would have a triangle that looks like this. We would have our reference triangle as 75 degrees, making A the opposite side of the triangle, B the adjacent, and C the hypotenuse. Since we have one unknown, we have three unknowns actually, we would have to find a way to make an equation with only one unknown so that we can find how tall the building is. And the only trigonometric ratio which will allow us to have that is tan, which is opposite over adjacent. Tan 75 will be equals to A over 100, A being the opposite of the triangle which we are trying to find. A would then be equals to tan 75 multiplied by 100, and A would be equals to 373 meters. This is how tall the building would be. Thank you for listening.